Well, hello everyone. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs & Stratton Energy Solutions. Today we're going to be talking about energy storage systems in harsh weather conditions. We're going to spend most of our time talking about batteries in cold weather, although we'll talk about some of the other situations as well. A couple of housekeeping items before we get started. This is being recorded. Everybody who attends will get a copy of the recording as well as a copy of the slide deck. This course is also approved by NABCEP so that I can issue continuing education credits. If you are here for NABCEP credits, at the end of the talk, my email is going to pop up. Please email me your name and I'll go ahead and issue you the credits. Lastly, the Q&A is open. So put any questions or comments or feedback, anything you've got into the Q&A, and I'll take a look at that as we go along the course. And then at the end, we'll take a look as well. Well, welcome everyone and thank you. I found this picture. I really like this picture here. It kind of just talks a little bit about how old Briggs & Stratton is. We're a 115-year-old company. What we're looking at in this right-hand side of this slide here, this picture is a lady with a Briggs & Stratton power wheel. Now, a power wheel is an engine with a wheel attached to it, and she's on a snow sled. So it was really cool to find this in the Briggs & Stratton archives. And it just kind of goes to show you that as a company who's been around a long time, we have a lot of engineering resources, tech resources, technical support resources as well, to be there as a partner to you whenever you're going to be doing an install. We're not going anywhere. We offer a 15-year warranty on our battery, and we're going to be here for 15 more years and beyond to support that warranty when the time comes. There's a lot of new people coming into the energy storage market, and who's to say they're going to be there and last. But Briggs & Stratton, as you can see, has been around for a long time, and cold weather is not new to us. Pretty exciting to see. Another fun thing to see is we're going to be hosting an event in Milwaukee. So speaking of cold weather, if you want to come to Milwaukee in March, we're going to be hosting an event at our headquarters. That's a picture of it there on the right-hand side. March 16th from 9 a.m. to 4 p.m. Here's the schedule. One notable thing is we're going to be hosting Ryan Mayfield. Ryan Mayfield will be there giving an hour-and-a-half talk on the NFPA 855 and fire and building codes related to energy storage systems. So not only are you going to have opportunity to learn, but we're also going to be giving a tour of that museum so you can actually see one of those power wheels that I showed you in that previous picture in person, as well as a lot of other go-karts and engines and many other lawnmowers, of course, that you'll see at our museum. We'll also take people out to our power lab, which is a fully operational energy storage system, and walk through all the different parts and pieces. This is a free event. I'm going to put the link to RSVP for that in the email I sent out with the recording and the credits if you have them. But if you also want to just get out your phone and scan the QR code here, coming up in March, we're going to have an event at the Briggs & Stratton headquarters. I hope you can join us. We're also going to have presentations from some of the other companies that have participated in developing that power lab or our power training facility. We're also going to be serving breakfast, lunch, and also have free transportation back to downtown hotels as well. So I look forward to seeing everybody there. It's a great way to get out to Milwaukee in March and kind of appreciate that cold weather. So, you know, if anybody had just gotten back from Intersolar, Intersolar was down in San Diego last week. And it was a great opportunity to kind of spend a little time in the Solarc booth. Now, Solarc has just come out with the Solarc 18K, which is one of the largest hybrid residential inverters on the market, 18,000 watts from batteries to load. Pretty exciting. But they also were showing off their new Solarc 12K, which is an improvement on an existing product, right? It's not a brand new product. It's an existing upgrade. And a lot of cool, interesting things. They've gone from 63 amps of pass-through to 100 amps. They've redesigned some of the knockouts. They've increased the amount of solar you can pull into it. They've increased the power that's supplied to a rapid shutdown transmitter, so you can have that all internal in the Solarc now. A lot of cool things. I'm really excited to see our Simplify 6.6 battery, which is what you see here on the picture, paired up with the SolarArc inverters. They've just been a workhorse of a hybrid inverter, being able to take all those parts and pieces and put it into one. But also at the show, EG4 was there, and I'm also excited to announce that partnership as well. EG4, of course, has the the EG4 12K and EG4 18K PV, the hybrid inverters. But what's really exciting about EG4 is their FlexBoss GridBoss combination. Now, we will have upcoming trainings where we'll talk about that combination, while all of its advantages. But just suffice it to say that you're kind of decoupling with the GridBoss. You're decoupling where the transfer switch is. You're moving it outside of the hybrid inverter into a GridBoss, into a gateway first architecture. And that results in a lot of flexibility on where you can put the battery and the inverter, and where you can put this grid interactive device, or the MIDI. The GridBoss has a number of other advantages, such as multiple smart ports, a large 125 amp generator input, a grid bypass built into it, and then additionally a service rated entrance disconnect. So SolarArc, EG4, both great partners with us, and we look forward to seeing pictures of your installs coming up with these two product lines. Let's dive right into it. As I said at the beginning, one of the biggest problems we have with lithium-ion batteries is cold weather. So let's kind of walk through. This was some resources I found here. What we're looking at on the right-hand side is charging a lithium-ion battery cell in normal conditions. So we have the cathode, the positive side, the anode, the negative side, and lithium ions like to live in the cathode side. They want to be over there on the left-hand side. But what we do when we charge up a battery, we pump electrons, the lithium ions electrons, from the cathode over to the anode side. And these lithium ions want to be with their electrons. So they're gonna follow them over, and they're gonna start to reside and live over here in the anode. That's not a problem in normal temperatures. There's a separator film right between the negative and the positive, and then there's a liquid electrolyte in between. And this allows the lithium ions to migrate over and live over there in the anode. Now, when we put a load on down here, the electrons are going to want to follow their lithium ions back. So they're gonna follow over here and come over to this side. So we're gonna allow the electrons to come over and live with their lithium ions. Now, in cold weather, what can happen, and let's go over here to the right-hand side diagram, is that in cold weather, this liquid electrolyte can become thick, like molasses. And what that does is it impedes the ability for those lithium ions to migrate. They go slower. Also, what can happen is that these lithium ions have a tough time making their way into the anode side of things. And they can start to deposit themselves or become trapped here and form crystals, dendrites. And these dendrites can build up. And if it becomes severe enough, they can actually puncture the separator film, causing a short in the battery. So that's the kind of the chemistry or the physics behind why cold weather is bad for lithium ion batteries, is that they can't make their way in, and they're slowed down trying to get through this electrolyte here. This can cause permanent damage to the battery. It can cause a loss of capacity in cold temperature as well. So, what's another exciting thing, and I've been looking at the weather this morning, that the East Coast is getting hit with a lot of cold weather, is that this problem isn't just specific to residential home batteries, it's also specific to EV batteries as well. So again, the viscosity change in that electrolyte leads to that sluggish ion transportation of those lithium ions, and can result in low performance. And I've seen pictures, of those EVs stuck on the side of the road. Does anybody on this call have an EV car that notices a loss in range during cold weather. I'll put it into the Q&A and let me know here. So one way we can mitigate this problem is, of course, battery heaters. We can have essentially a parasitic load that uses energy stored in the battery to heat itself up, resulting in that ability for that electrolyte to warm up, and we can get that migration of the lithium ions. Another way to do this is to choose specific cell types and also electrolyte materials, so that the electrolyte material we choose in the construction of the battery becomes less thick as temperature gets colder, allowing for better performance as well. Some other things we're going to talk about is how a battery management system can also play a role in this. And the idea here is that this is a fundamental principle of these lithium-ion batteries. And the way we mitigate that is through several ways, like I just alluded to. So what we've been talking about so far is the charging cycle. Now, another problem can come up when we're discharging a battery under cold temperatures. And what we're looking at here on the right-hand side is this chart here. And this was an experiment run by my old boss, Nathan Heston, down at Cal Poly. And essentially what they had done is taken lithium-ion battery cells, submerged them in oil that was being temperature controlled. So any battery that's being charged or discharged is going to warm itself up due to the internal resistance in that battery. But this experiment was trying to mitigate that effect by cooling the battery during this discharge cycle. And what we see here is over here, right, these are batteries at warm temperatures in the bath. And then here we're getting colder as we get down to 0 degrees Celsius or freezing. We got voltage on the y-axis and we got depth of discharge on the x-axis. So as the battery is being discharged, you can see that we're getting more and more discharged, and the voltage of the battery is starting to drop here. And you notice that the batteries in the warmer conditions over here make it pretty far, right? They got a pretty flat curve, and at some point they drop off that cliff, and then they go to 0% state of charge. But the cold batteries here, they maybe even at around 50% state of charge are already starting to drop off. And what this is kind of doing is that lithium-ion batteries in cold temperatures can't discharge themselves all the way. The voltage is going to start to drop off pretty rapidly. The battery management system is going to recognize this as a depleted battery and not continue to discharge the battery. So the idea here is that not only do we get problems on the charging cycle, but when we have a cold battery and we're discharging it, we're not able to get all of that energy out of the battery. And as you can see, maybe even just 60% of the battery's capacity is usable when we have a really cold battery. So this is kind of on the right-hand side, again, showing the cell construction, the cathode, the anode side right there. And then also keep in mind that different form factors can also have an effect. And mainly a lot of that has to do with the conduction of the heat loss out of a battery. Some of these prismatic cells have a lot more surface area relative to the cell size, as well as the cylindrical in the pouch. So all these play a role in how the heat is lost out of a battery. So when we look at this picture here, first thing I noticed is, well, the snow, of course, but also those solar modules, how steeply tilted they are. This has got to be a northern latitude location, and it's winter, and we're trying to capture the sun, which is just barely coming up over the horizon every day. So we're going to tilt those solar modules up, get them pointed perpendicular to the sun rays, try and capture that sun. In the background there, I see a little shack there. And keep in mind that when we say, 0 degrees, the batteries can only work down to a certain temperature. That's not necessarily ambient temperature. A lot of times we're going to put batteries, especially in a situation like this, we're not just going to put them out in the snow, or we're going to put them in a structure. And that structure can be insulated. It might even have a heating system on its own to heat it. And I can almost notice that here because I see some of the snow melting off of this roof right here. So keep in mind that the batteries aren't necessarily at the ambient temperature. I also think about nighttime radiation loss. So if you got a metal cabinet that's sitting out in an open field with a clear sky, we're going to get a lot of radiation loss. Well, if we're able to put it under a cover or put it inside somewhere, we're not going to get that nighttime radiation loss. We're not going to get any convection loss through cold air blowing across it. And we're going to reduce that conduction loss by insulating that structure as well. And I said it earlier that batteries during their charge and discharge cycle warm themselves up because of their internal resistance. But if you put a battery out in cold weather, I got it down there at the bottom, you're going to see a loss of capacity. We just talked about that. You might have a loss of cycle life because of damaging the battery. And, really you could almost destroy the battery if you continue to charge it at very cold temperatures. So I kind of already showed this, but I'm going to lead it here into the next slide, is that we do have a simplified 6.6 battery. It stacks together. In the picture on the left, I can tell that's a marketing photo because I don't see any warning stickers from PV labels. I don't really see a lot of conduit coming down from the solar. Maybe they did a really good job, but that's there with the solar. And I think it looks great in that photo. And a good looking battery does matter. But here's where the Simplify 6.6 battery management comes into play. So if you have a battery with that solar converter I just showed you, and it's really cold out, the battery and the solar can talk to each other through closed loop communications. The battery management system in that Simplify 6.6 battery knows its internal cell temperatures. It knows the inside temperature. And based on the temperature it sees, it can tell the solar through that closed loop communication that, hey, I'm starting to get cold. I want you to slow down my charge rate. And at some point, if it gets too cold, we'll just simply tell the solar to stop charging me. So we want to make sure that whenever we're commissioning these systems that we check the Solarc or the EG4 to make sure that those closed loop communications are established and working properly so that if it does get too cold, we're not going to destroy a battery in cold weather because we're not going to charge it. And we're not going to charge it because we've told that BOS or the balance of system, that inverter, that I'm too cold battery, please stop charging me inverter. So that's definitely a fail-safe way to make sure these systems don't destroy themselves. One thing we did do in the Simplify 6.6 is optimize that electrolyte. A lot of our competition, their batteries can go down to 32 degrees, 0 Celsius. Any colder than that, they're going to activate battery warmers, heating pads. And some of these heating pads can be significant draws. Of course, they're on a thermostat, so they're with the differential, so they're not going to be constantly running. They're going to warm the battery up, shut off, and rinse and repeat. The Simplify 6.6 does not have a battery heater. We took the approach that we're going to optimize that electrolyte. And if we kind of look down on the bottom right-hand side, the charge temperature is able to get down to 14 degrees Fahrenheit without the need for heaters. And I'm sorry, I should put that in as Celsius as well. But what that results in is that a battery that can operate in a wide range of temperatures without needing a 300-watt heater to warm itself up per maybe battery module as well. Now, again, I was checking the temperatures on the East Coast, is that obviously it's getting colder than 14 degrees. But if we can put the battery in a garage, in a basement, in a utility closet, a lot of times those spaces are adjacent to the home, and there's going to be, although they're probably insulated, there's going to be some heat that leaks from the home into these garages, into these basements. So ambient temperature isn't going to really be less than 14 degrees. And if it was, you probably have your pipes bursting as well. So it's a great approach to be able to accomplish cold weather performance without the need for a 300-watt heater. A 300-watt heater operating for 10 hours, you just used 3 kilowatt hours in just a parasitic load heating the battery. So very interesting approach, and I'm really excited to offer this option where we're not draining the battery to heat itself. All of the batteries do have a controller up top. The controller up top is where we have the power button, the fuel gauge. And also, as an American company, Briggs & Stratton understands the installer market. And we've done a 2-inch knockout pre-punched on top of the battery controller so that you can simply run your conduit. There's not cable glands or weird connectors where you have bare exposed battery cables. All of the batteries stacked together using rapid stack connectors, and they're all kind of held in place with these alignment pins with little screws that go in. Speaking of the different chemistries, lithium iron phosphate, there's a reason we choose that for the home storage, right? Lithium iron phosphate has some advantages. Its cycle life, its ability to operate quickly and discharge quickly and charge quickly. One of the drawbacks to lithium iron phosphate, though, is its energy density. It's somewhat heavier and more bulkier, but with home residential storage, we're not moving the battery, right? It's just stationary on the home. The other big advantage from lithium iron phosphate is its safety profile. Cobalt, right? Cobalt's in our phones, in our laptops. Cobalt has a number of advantages, such as that energy density. It's a lot more lightweight, and it also can actually charge a little quicker and discharge a little quicker relative to lithium iron phosphate. One of the drawbacks from cobalt is that it doesn't necessarily have the same safety profile. But I would say this, that the safety profile of a battery shouldn't be based solely on the chemistry being leveraged. There's a number of advantages and reasons why there's a safe battery, such as those form factors, that cylindrical, prismatic, or pouch cells, the battery management systems and its protections, the overcurrent protection devices, the breakers and fuses, also the venting or the actual battery module construction. So, let's not take that too lightly. Of course, LFP is what we use in energy storage systems. Amazing cycle life. You can see up in the right-hand corner the 6,000 cycles we expect. That's at a C/2 charge or discharge rate. 6,000 divided by 365 is like 16 something years. If we're going to charge the battery a little quicker or discharge it a little quicker, 0.75 C, I think that's like charging it in about an hour and 15 minutes or discharging it in an hour and 15 minutes, 4,500 cycles. But most people aren't charging or discharging a battery that fast. Usually we charge it during the day from solar, and then we discharge it over the course of the night from the loads. We do have the battery and the inverters are both indoor or outdoor rated, so we're able to put them outside. So far we've been talking about cold temperature, but hot temperature can also affect the batteries. They're less of a design consideration. Our batteries can go up to 122 degrees Fahrenheit. And I'm looking at the right-hand picture here. I'm not sure if that's the Salton Sea or somewhere up in Nevada, but obviously it looks hot there. But you can see again that we have an enclosure for the battery. So we're not just putting them out in the hot sun right here. So similar to cold weather, we're using insulation to mitigate this as well. But if it does get too hot, that electrolyte, that material between the anode and the cathode can start to break down as well. I guess that would, bring up another question is, I'm talking a lot about batteries here, but think about the inverter. Think about the other parts and pieces of an energy storage system. If we have a home, and we got a good south-facing side of a home that we want to put the battery and the inverter in, yeah, it's gonna heat up that battery with the sun, but also the inverter and the other parts and pieces. And I've seen the screens, right? The LED screens on the inverters can get hit with the sun and burn out. I don't know if anybody's been to a red box or know what that is, but sometimes you'd see a red box in front of a 7-Eleven and they would have like a little flap, almost like a felt or some sort of piece of fabric that would drape over the screen of the inverter. You know, that may be an opportunity to protect that screen of the inverter, get a couple little magnets or something and hold it on. But cold weather, absolutely. Hot weather, humidity. This was another big one. So a lot of the battery cells are hermetically sealed, right? They're sealed. So we're not necessarily going to get humidity inside the battery cells, but we can get humidity inside the battery module. I'm thinking of the case of the battery, and that can pose problems with the negative and the positive terminals, and these sort of busing we have in there. Perhaps even the battery management system can be affected. Now, humidity by itself isn't really the problem. It's humidity that has salt contained in it, and that's really when you get near the ocean. So we actually have it in our warranty that if you're going to be within half a mile of a saltwater body, that you need to, it's okay, but you just have to put it inside of a garage, inside of a utility closet or a basement as well. I'm also thinking about the pool there as well. It looks as though they have like a screen, or maybe that's even a roof there, that corrosive chemicals, maybe that chlorine could also pose a problem to these batteries as well. I haven't seen that called out in any of the warranties. I like that install there. It looks like there's some maybe that Iron Ridge, or could be Unirack racking there with a Sola deck right there on that. And again, the idea here is that these cold weather temperatures, these hot weather temperatures also affect the performance of these solar modules, right? The colder it gets, voltage on those modules goes up. Warmer it gets, voltage goes down. The idea that we can also get corrosion around these solar modules as well. Altitude. The idea here is the main kind of takeaway is that as you go up in elevation, it gets colder because the air is less dense. And for even a given temperature and a higher altitude, the air being less dense has less ability to hold heat. And what that really results in is that the higher up you get, right, the colder it gets, and we can start to see those temperature considerations become more of a factor. But outside of that, also the lower the pressure, the less weight we have on any given body there. And if you think about a prismatic or a cylindrical cell, well, cylindrical, right? It's a cylinder. It's inherently a very strong shape. Prismatic cells are built, they usually have like little ridges, or they're able to contain themselves. Pouch cells by themselves have very little structure to them. So the lower the humidity, or the lower the pressure and the higher the altitude, you might have problems with a pouch cell. Now, most pouch cells are also contained inside a battery module where they're physically held together. But the point, kind of the takeaway of this slide, is that many of these battery cells, right, not only the construction of them, but also the chemistry or the way we work that electrolyte can affect their performance in cold weather and in high altitudes. And don't pay attention just to the batteries. As we look down there on the right-hand side, some of these inverters also have altitude limitations. Now, with the solar, and this may be the case with EG4, is that you can go above these elevations, but they might derate. Anybody on the call ever done an install, say above 10,000 feet? Put it in the Q&A and let me know. So let's look at some real pictures here. Now I did say earlier that the Simplify 6.6 does not have battery heaters. We do have our Phi and Amplify batteries do have heaters, optional heaters that can be installed. What we're looking at are some of our Boss cabinets, and these are full of batteries, 12 batteries each, about 45 kilowatt hours per cabinet. This is another battery cabinet with 6 batteries here, and this is actually a combiner. It just has giant copper plates in that where we're combining all of these batteries together. And then we have a row of solar converters. Those look to be 12K inverters because of the power button on the front there. And I suspect that we're stringing these in a 3-phase configuration because it looks like a commercial building. And I see, 2, 4, 6, 6 batteries. So I believe they're in a 3-phase application where we're strung them together. But, think about this metal cabinet sitting out there. What might we do inside that cabinet? Well, we could insulate it. And this is some older photos here. We have some Schneider equipment down there. That's either an XW Pro. I see a charge controller there. But look what they did in that top left corner. They had a battery box. Now, these are not lead acid batteries, so we don't need to vent them. We're not getting any hydrogen gas. But they took that rigid foam panels and really insulated them, not only on the base, but the sides and the tops, so that when these batteries are charging and discharging, they're going to create some of their own heat, and we're going to try and trap that heat inside of this battery box to keep them warm up here in this Montana enclosure. Another thing I noticed here is I would think that these batteries almost appear to be touching each other. So that would be a great opportunity if we wanted to keep them warm. We would actually have them touching. But this would be a bad idea in warm temperatures or hot temperatures. We would actually want an air gap between the batteries so that when they get really hot and warm, we're not trapping that heat in between the batteries, and we're able to have a little bit of air flow through there and cool the batteries off as well. Here's another great example. Again, we're looking at some of our Phi and Amplify batteries. What I noticed here in this picture is we got the wall mounts batteries. We got them all paralleled up. We got some combiners here, and then we're flowing here into this wiring trough over to these 2 Solarc 12Ks. But notice down here in this right-hand corner, that to me looks like a propane heater. I can see, of course, it's plugged into the wall for the igniter and a fan probably. But then I see this little yellow gas pipe. So this is an interesting way to do it. We have a room that's insulated that is not being heated by electricity, right? We worked hard to make that electricity. We took those solar panels through a charge controller. We put them into the batteries. And then what are we going to do? We're going to turn it into we're going to take a toaster oven and a resistive heater and just burn that electricity. This was an interesting approach where, yeah, it needs a little bit of electricity, but most of the energy is coming from, I would guess, a propane tank to heat this room. And I'm sure they're not heating it to 65 degrees. They're probably keeping it maybe 40 degrees, just warm enough so those batteries can work. If we were to use electricity to heat this room, a heat pump would be probably the best option. And yeah, heat pumps do derate under very cold ambient temperatures, but there's been a lot of advancements in heat pump technology where they may be able to accomplish the little bit of heating we need to keep this battery room warm. Here's an example of some warm temperatures here. Again, what I'm noticing here is a lot of insulation on these systems. I do notice the batteries are pretty close together here. I notice a lot of these charge controllers are pretty close together as well. Those will tend to get warm if you're processing those midnight solar charge controllers there. Those can tend to build up some heat as well, especially when they're processing a lot of solar. But again, the idea here is we're keeping it out direct sunlight in an insulated space. Well, we can sit here and talk about how good our batteries are at some of these extreme environments, but you don't have to take our word for it. And a lot of the other batteries in the industry have to go through third-party testing, right? We have to obtain our UL 9540. Part of that is being informed by the 9540A large-scale fire test, as well as UL 1973 on the battery and 1642 on the cell level. So a lot of these tests, especially the 9540A, are very rigorous, where they put them into thermal runaway event and watch what happens to show their safety. Another test we have to do is UN. So whenever you might see this whenever you ship a battery, or any dangerous good, there's a UN number on here. And what this allows us to do is to ship the batteries specifically on airplanes. And what we did is we sent this battery off to a third-party tester. And the idea here is that they kind of simulate what a battery might experience in the cargo hold of an aircraft. So what happens in the cargo hold of an aircraft? Well, the altitude or the pressure on the battery changes. So what they do is they adjust that altitude and vary it to test the battery. Also, think about if we're in an airplane, belly of an airplane, we go up to high altitude where it's cold, and then we come back down and land. We could have rapid cycling of temperature as well. It's vibrating. My flight down to Intersolar was the huge West Coast storm. It was a lot of turbulence. So imagine, what it's like down in the cargo hold as well. So they're shaking it, and then they also do shock, right? When you land on the runway. So what we did is we send our batteries out to pass the test. There had to be no leakage, no venting of the battery. It couldn't come apart, no disassembly, no rupture, and no fire. And then what they did is they tested the voltage of the battery directly after this testing to make sure it hadn't lost any of its capacity to store energy. And so we were able to achieve this, and so we can airship the batteries. Additionally, after those tests, what they do is they short circuit it, and then they watch until to see if it's going to catch fire, essentially, not to pass or get above 170 degrees Celsius as well. And then they overcharge it as well, 1.2 times its max charge voltage. Again, the criteria to pass is that it does not catch fire. So I'm happy that do that. And, thinking about that plane ride, you hear about this when you're doing the safety briefing, that the flight attendants or the announcement will say, if you've dropped your phone in between the seats, don't recline your seat. They don't want you to crush that and short circuit your phone battery. If you feel your small electronics devices overheating, let a fire attendant know. I've heard that they have little bags, some sort of fireproof bag that they're going to shove your phone in so you don't get a fire inside an airplane. It's very interesting, but it goes to show you how much safety we think about in these systems. And when we're putting it on somebody's home and they might have fear of the batteries, keep in mind, show them the test reports or talk through it with them. So absolutely, Briggs & Stratton makes a great battery, our Simplify 6.6 battery. You stack them up, you get a 20 kilowatt hour stack of 3 modules, very quick discharge. So just one stack of 3 is capable of handling 14,000 watts continuous that's a perfect pairing for a Solarc 15K. But generators also come with their own cold weather considerations. Quickly, what I'll show, and sorry everyone, I didn't update this slide, but the Power Protect 10, the one on the far left-hand side, has been discontinued. But we have our vertical Power Protect 13, 18, 22, and 26. These are all air-cooled. They either operate on natural gas or propane. And then the commercial line is liquid-cooled, and those can also operate on propane or natural gas. Quickly, NG Max, what you see down in the right-hand corner there is a lot of our competition in the generator marketplace will sell you, say, a 22K generator. That 22K generator is rated on propane. If you go to run that 22K generator on natural gas, it derates, maybe, let's say, down to 18.5 or 20.5. What the engineers have done here at Briggs & Stratton has optimized, I believe it's the ignition timing, the intake and exhaust manifolds, so that when you run one of our generators, you're going to get the most power out of natural gas as you would with propane. For example, the 18 and 22 do not derate at all, and the 26 and 13 derate a little, but not as much as they would without that technology. So in a generator, we have a battery in the generator. It's our battery to start the generator, to hit that starting motor and get the generator engine running. Now, the type of lead acid battery that we're seeing here changes a little bit, and I looked and went into the instruction manuals for our generators, and it says, right, if you're in San Diego, you're in somewhere that's warm most of the time, especially when the generator might be starting, which might be the dead of winter. Group 26 or group 51, right? 540 cold cranking amps. If you're going to be somewhere where it gets below 30 degrees Fahrenheit, group 24, it gives you more cold cranking amps so that when that battery does get cold, it's still going to be able to start up our generator engine. And that kind of makes me think about, most people think of a generator as always sending power from a generator into a home. But what maybe you guys on the call realize, but not everyone else, is that you're also constantly sending power to the generator, even when the generator is not running, to keep that starting battery that I just showed you on a battery tender so it's charged up, but also to power some of these cold weather accessories that we see on the screen here. Down here on the left-hand side, there is the oil warmer. So that we're able to warm that. You kind of shove this underneath the crankcase of the engine. It can warm it up. And I believe we also have some newer ways of doing this where you actually insert a heating element into the oil sump, and it will warm up the oil in that fashion. I think that's probably a little bit more efficient because we're getting more direct content with the material we're trying to warm. Even though we maybe have that Group 24 battery, we still have to put a battery warmer. It's similar to what we do with these lithium-ion battery warmers, is that we just put a heating pad underneath the battery to keep that starting battery warm here as well. And then one thing we don't have on batteries, but we do have on generators, is the fuel regulator. So there's another heating kit here to be able to keep that so the fuel doesn't freeze in the lines and prevent the generator from running. So it's interesting to think that there's these cold weather considerations, not just on the energy storage side, but when we're taking a battery, combining it with an energy storage system, that we're complementing the two together, that we do have these considerations as well. And we should think about these when we're doing our load calcs. Again, all of the things here that you see, just like the battery warmers, on a thermostat, and they're going to cycle on and off as they go through that differential. Another thing is propane. So when I say a propane generator, Well, some of the larger generators actually do run on liquid propane, but our air-cooled generators run on propane vapor. So if we have this tank here, we got liquid propane on the bottom, just like our barbecues. We're not capturing the liquid, we're capturing the vapor that is evaporating off of this liquid propane, and it evaporates at very low temperatures. But if it starts to get too cold, the amount of vaporization we get decreases, and we're not able to supply the amount of fuel we need to keep a generator running, especially maybe under a large load. So one way to do this is to keep the tank warm is to bury the tank, right? As we go down in the ground, it stays warmer. Um, we can also use heaters or insulating wraps around the propane tanks, and you see a couple of examples there as well. And again, these are all on preset thermostats, but it's interesting to see that these are all parasitic loads. All of these heating options, um, it would be acceptable to have these parasitic loads to make sure that we have a functioning system in all of the climates that we might expect these homeowners to live as well. I think the burying it right is the least um, has the least parasitic load because we're using the earth to warm the battery, whereas these tank heaters obviously are going to have a certain wattage associated with them, which I'm not sure what it is. So, I kind of spent a lot of time talking about these cold weather applications. I do want to wrap it back around. Kind of my final thoughts here is we need to be able to provide backup and also the ability to participate in time of use rates or VPPs during all sorts of climates, in all sorts of climates at different altitudes, different proximities to bodies of water, and humidity, and also temperatures as well. So ideally, we're going to put these things inside of a garage, inside of a basement, a utility closet, or maybe even build a structure. When we can't, we're going to use some of the mitigating factors we talked about, like the heaters or the ability to also maybe build an awning over it or insulate those structures as well. Really excited about the Simplify 6.6. It's easy to install. I've been able to stack it in just about 15 minutes. We have very powerful apps control this, and that brings me back around to the idea that even if it does get cold, the battery management system can tell that piece of charging equipment to slow down. Really excited about our brand. Most homeowners in the United States have at one point had a lawnmower from Briggs and Stratton, so they recognize that name brand. That brand also correlates with the engineering team and the truly huge, massive resources that a large company like Briggs and Stratton can bring to the table, and our expertise of American manufacturing as well. Our battery is designed to work with many other inverters. We make a great battery. We'll let you, the installer, choose the inverter that you like, whether that be EG4, Solarc, other ones as well, Solus, Growatt, Mega Revo. You choose the inverter you like to work with, you're comfortable with, and we'll sit there provide you a great battery. We're not going to play the game where you call us and we'll say, well, it's not our battery, it's the inverter. That's not our ethos. Our tech support team, myself included, know a lot about the Solarcs, the EG4s. We're going to do everything we can to help solve your issues without sending you on to them. And part of that also is integration guides, manuals that we developed specifically for our battery with other people's inverters. One way you can continue to learn more is by joining the Power Academy. Power Academy, one of the best parts about the Power Academy is the self-paced e-learning courses where you can jump on there, learn at your own rate. You want to learn how to install that heater for that generator? There's a Power Academy course for that. We also offer in-person classes. And also Power Academy Live, very similar to what we're doing here, where we have live sessions that are interactive as well. Lastly, I'll end with promotions. We have some opportunities for $1,000 off your first install. After you've done your first install, we'll give you $100 back for every battery you install. And then we'll let you into that's where your opportunity to join the IQ program. So $1,000 your first install. Once you do that, we'll let you into our installer program. There's a quick test you got to do, and we'll start to offer you $100 off every battery you do. But I think a lot of the valuable here is the opportunity to get leads beyond the tech support approval list for trip service trip reimbursements, and also have that kind of direct phone line to our tech support as well. So reach out if you want to be part of that IQ installer program. If you have done an install, you didn't get your $1,000, let me know. I'll see what I can do. If you're here for NABCEP credits, please email energystoragetraining@basco.com. Energy Storage Training at BASCO. It stands for Briggs and Stratton Company.com. We have engineers on staff ready to answer any questions you might need. I hope that you can make it to our event up in Milwaukee coming up in March. We can enjoy the cold weather together and talk about all of the mitigating factors that you might have done on some of your installs. Thank you, everyone. I'm Daniel Moyer from Briggs & Stratton Energy Solutions. If you need those NABCEP credits, please email energystoragetraining@basco.com. We'll see everybody at the next one. And let's see if we have any questions. I don't see any questions. If anybody does, go ahead and respond to my email, and we'll get your questions answered at that point. All right. Take care, everyone.